My name is Andriy Lyubchyk and I'm CEO of CascataChuva company. It's a small startup from Portugal. I'm also working as a professor in Lusófona University here in Lisbon.
I'm Sergiy Lyubchyk, so actually Andriy is my brother and we are twins. And we both launched CascataChuva company. I'm the CTO there. I also a chemical engineer due to my background. So we studied a year and finished our PhD in Portugal in different universities, but then we joined together our forces in order to create something new.
And I would like to share with you my pessimistic idea about the future. It's the wars that are continuously going on in our planet, because I'm originally Ukrainian and what's going on right now is affecting our lives and our relatives. I would prefer to explore the space, explore other planets than to have war.
Respect each other and our nature, and like that we can create something very good.
Future Optimist.
Welcome to the show, Sergey, Andriy. Pleasure to have you, and may all wars stop. That is certainly something to be pessimistic, or at least afraid of. And I'm very excited to welcome you to the show, because what you're talking about is truly insane. In fact, it's so insane as to defy belief, because your technology, the claim is to be able to get essentially limitless electricity from the humid air, which on its face sounds utterly impossible. So before we jump into this, is it utterly impossible? Is this absolute nonsense, or is it actually something that can happen?
We're already exploring. So we want to create a real scale device to harvest energy, electrical energy, out of the atmospheric humidity. So this is our target right now. That's why we launched the company, actually, because from the lab we find out that it's possible. We made a proof of concept, and currently we are hardly working on the real scale device.
Wow, incredible. Because every so often in humanity, you get these types of things that seem to change everything. Like, people will say that Nikola Tesla, many years ago, he was working on a way to harness electricity from the atmosphere, or to, with all of his crazy technology, but unfortunately his lab was burned down, or he didn't have the funding. Every 50 years, you hear about some kind of miracle technology that would completely change our understanding of physics or thermodynamics or something about our existence. This seems to be something along that scale. So how did you come up with the concept that you might be able to get energy
It happened
from
by
humidity?
chance. So we were, at that time, we were just PhD students working on implementation of the project for the air purification. So it was 2012, I think, or 2013. We've been working in the lab, and the target of the project was to kill airborne viruses and bacteria. And for that, we used the material that generate oxygen reactive species interacting with the atmospheric oxygen. And so we were trying different materials, and particularly one we are working right now. During some electrical measurements, we find out there was some interference of the result. So why that happens? We figure out a bit later it was a breathing of the experimentator. And like this, we start moving on. We find out that it was not the heat, nothing, not light, but the breathing and actually the atmospheric humidity or humidity itself that were affecting the measurement. So it means that humidity can generate some electrical signals during the interaction with our material. So the first year we were absolutely crazy, because we've been talking to many different professors and other people. Imagine we have a sample like this and we were breathing. One guy was putting the electron voltmeter there. The second was breathing absolutely red, because we were trying to get as much as possible to see that the voltage actually increases. And yeah, we applied for the first funding through the European Horizon 2020 program, and we've been successful. So we used that money to make the proof of concept for the process, make some real working samples, and at the end, we made it. We find out, we end up with conclusion that this process is possible. In parallel, we
Wow.
find out that several groups around the world also started the same work. And I think for some of them, they had absolutely the same beginning of this process, some measurements interference or something. Yeah. So one group was in China, then in United States, Singapore, and I think we are the only group now here in Europe.
Wow, that's insane.
Yeah, I just want to add that time it was only a way to breathe a lot on this sample to get more energy. Not
Some
energy,
signal, yeah.
but voltage. Yeah, to show, to have an evidence that we were working with the technology that converts humidity. Really,
So what's the status of it today? How much electricity have you successfully generated? Is it still proof of concept, or have you successfully implemented it
We
at some
are
kind of
at
scale?
lab scale. So let's say we are at TRL 4 right now and moving towards TRL 5. And then this is our plan for this year. It's very optimistic. We want by the end of this year to have design of the engineered prototype ready. In engineering prototype, it will be a device of 1 cubic meter that will generate 10 kilowatt hours of electrical energy. Despite these numbers say not much about how it works and is it big or not, or set the dimension based on the energy we want to get at the end of the day. So these 10 kilowatt hours, it's something that the regular household uses during one day. So it's
Okay.
well, unless you have
That's the typical.
up to 200 square meters.
Okay.
Up to
So that's
unless
a
of course you
significant
have
target. And you said 1 cubic meter. So something like a
yeah
refrigerator in
yeah
your home could generate all of the energy for your
yeah
home. Is that what you're realistically hoping
exactly.
for?
Yeah, but it will be like a Lego puzzle, so we can design a device from the smaller pieces because our single disk conversion unit is 4 per 4 centimeter size, and it will be thousands, tens of thousands of these small devices in this big box. And
Wow.
to create this device, we are limited by the industrial production machine. So to have this 4 per 4 centimeters device, we use a machine that like 2 floor buildings tall and around 15 tons in weight. So it's very big machine to produce these very small pieces that we use
Mm.
for the
So
creation of the device.
does it work like a fan where it's circulating the air inside somebody's home, or where is it actually getting
So
this
you
humidity
get right
from?
to the point because it's a bit more. It's deeper than the you can assume from the first side of your question because we are not using any fans or any input energy for device to be operated. So everything done by only physical phenomena of our nature. So in
What?
this case, we are talking about the diffusion. We have a diffusion of all the gases inside the atmosphere, including the humidity. And so by just diffusion, you always will have the same amount of the humidity at every single place of the around the device. Of course, the device will bring some changes to it if we are talking about the closed volume. So if, for example, you want to use it in your basement, then you have to have access to the humidity. Without humidity, the process won't go. And the first physical principle that goes act as a driving force for the process to go if it's adsorption. Adsorption is not like absorption. Many people miss between these two
Right.
terms, absorption and adsorption. Absorption, it usually applies to the light. It absorb inside the media, inside the bulk. And the process I'm talking is the surface process. So it happens on the surface. We made the materials that is very porous inside. 1 gram of the material we are using has 1,000 square meters specific surface area per gram of this material. So 1,000 square meters per gram is not that much. There is exist materials like aerogels that have way bigger surface inside, but 1,000 square meters is I don't know what half of
That's a
that
lot.
or
That's
one,
huge.
one
Yeah.
football field. Yeah,
Right.
inside
small field.
inside
Yeah.
this small
Inside
amount
it
of
a
the
little bit.
material. Yeah. And then
Wow.
it's act like a pump. When it's dry and nothing inside, it just soak everything inside, including the humidity, and then the process starts.
So
This is a
does it output water, or is there a byproduct? What comes out? Does it
yes, of
collect
course.
water?
There's outgoing gases. We have some chemical reactions that happens on the electrodes of the device, and this is basically water, some amount of hydrogen and oxygen.
Hmm.
This is what happened.
And you said it's not plugged in, so you don't have to It just works with no energy coming in. It literally just
It's
produces energy.
absolutely same way as happened to the solars. So you
Okay.
just put it under the sunlight and it starts generate something.
So then would you want to keep this outside? It's something that you put on the roof or in the yard so that it has a constant supply of humidity? Because if you put it in a basement, will it just dry out the basement and then
But
it's
usually,
done?
according to my experience, the basement is always wet. You can try to dry it as much as you
There's
want.
a mathematical certainty.
Yeah.
No matter what, the basement
Yeah.
is wet. Okay.
Yes. Yeah,
No,
this
but
is the
just
main
re-
condition. So
Yeah.
here we have advantage of to other technologies like wind, solar, other renewable technologies. We can install it anywhere. The only criteria that has to be met is the atmospheric humidity, the presence of atmospheric humidity. Also, I'd like to mention that it works from start, produce very stable, good signal, starting from 20% of relative humidity up to 100% of relative humidity. The more humidity you have, the better.
Right. So unlike solar where it's dependent on whether the sun shines or not in the area, in your case, because there's a universal law that says the basement is always wet, it will work anywhere on Earth.
But of course, we also have some limitations, and
Right.
I'm talking now about the source itself.
Yeah.
Sun as the source of the energy is way greater than the humidity. So the only way we want to, let's say, compete between these sources is that our technology will be working continuously 24 hours, 7 days per week. So it will be continuously working non-stop. And that's how we are aiming to achieve similar energy out, similar to solars. In terms of LCOE parameter, LCOE is levelized cost of energy. So the parameter that allows to compare between different technologies, between grid or whatsoever. So it's how much your 1 kilowatt or 1 megawatt of energy you are producing cost. So our predictions for the next step of the development of the company, which will be the pilot production line manufacturing with limited capacity of these cubic meter devices production, will be about 17.5 cents per 1 kilowatt hour. So this is more expensive, like 3-5 times more expensive comparing to solars, to the wind, offshore wind. But still, it's a promising result, and we are aiming to even decrease it for the full-scale manufacturing stage.
That's incredible. So does it have any moving parts or anything that needs to be replaced, like a water filter? Is it just you let it run and at a certain point you got to swap out the
We
elements?
don't have yet the final design, so everything we are going to say right now, it will be just imaginary things or something that we discuss among our team recently. Our technology will, of course, has some disadvantages, and the first one is similar to the solars. It's that it's need to be protected additionally from the dust. So you cannot just put it and it works continuously with no effect of any other thing. So the dust can, of course, affect. It can block the pores of the materials. So this is the one of the biggest challenges we see now. So we are considering the EPA filters, that's very simple ones with the big size of the pores. It's I believe half of micron, 1 micron or a bit more, which will easily allow the water pass through the gas phase water, but protect from the dust. So these parts will need to be definitely replaced from time to time.
So there are some kinks to be worked out, which makes sense. At one point somewhere you said that you believe there's the potential to meet 500 times the current global energy needs, which is crazy. Do you envision something like that happening by every home having a device like this inside the home? Or do you think the future is more about giant centralized devices that are
Don't
powering
ask
a
me
whole
these
town?
questions because this is real future. It's my dream, in fact, because I consider this technology in the future will not be used as this type of the solution as solars or additional box to your house. I believe that in the future we will build houses using our material. So when entire house will be a big generating unit. So your house itself, it uses a lot of materials. So we use way more materials to build some construction to have our houses, homes, or whatever else. And this is what we want to move on in the future. But first things first, we will focus on the modules, and it will take lots of time. if we would compare our technology, at least the way it was developed with solars, when they started in 70s and only in 2010, with all the changes of the market for their materials, the monocrystalline silicon solar cell become really competitive on the market. So it's around 40 years
Took a
from the
while, yeah.
development till the
Yeah.
market makes. We hope it will be a bit faster. So yeah, we have some example of solars that already passed this way. So let's see. We
Okay.
hope at least 7-10 years, and it will be a mass production.
Well, it's certainly a noble goal. I love the idea of every home and everything being built from this
Yeah.
material. Skyscrapers, obviously, that's incredible. That clearly sounds like the future. Limitless energy seems possible. One of the criticisms of existing eco power solutions like solar and wind is that obviously if the sun's not shining, you don't get the solar energy. If the wind isn't blowing, you don't get the windmill energy. So a lot of people say generating the power is not necessarily the biggest issue, but storing it, making it meaningful. We don't have the battery technology to do that, especially at scale when you're not talking about kilowatt hours, but megawatt hours and gigawatt hours. The storage of that energy becomes, up until now, impossible with our current battery technology. Do you think that unlike the other types of energy, this is one of the only ones that would be completely independent of those types of fluctuations? For example, it works at night, it works during the day, it works basically year round. So would it lessen the need for battery storage, do
No,
you think?
I don't think so, because we don't use the energy continuous. In fact, we are using it, but if we are talking about the households, it depends on the person, of course, but from 50 to 80% of your time, you're outside or doing something at your work.
Not
So
me.
you
I'm at
don't,
my computer 24 hours a day. I'm
yeah,
burning through gas every second of every day. I don't even know what the outside looks like. I live in
okay.
this
So then
cube.
it's probably a good choice for you.
Yeah.
Because
I need
it can be directly plugged and supply everything you use continuously. But as I mentioned itself, the source as humidity is not that much energy efficient. In order to accumulate the certain amount of energy, you need the technology to work for a while. So will be not high peak generation or high generation since you just put it on the place where you want it to be. So you need to store some energy. So we definitely will need some storage unit in order to get this energy in one place and then use it whenever you need to supply anything you need. Absolutely the same as solars.
Okay. To the critics out there who might think that it's not physically possible, because I've seen some people who are not sure about technology like this in general. How would you address that? Do you say, yes, it is possible, or we're working on it? What do they have
Very
a
easy. We
point?
invite everyone to our lab to see it, to touch, to grab, to break, to measure. Yeah, I will say this probably in ahead because we might touch this question later. But of course, even some very big worldwide known companies get interested what we are saying, and they've been to our lab, and we get some connection. They have our samples. They saw everything we are doing. And yes, and some of them has asked more samples, so we have signed some NDAs, some agreements, so we send our samples almost everywhere to who are interested to see, to test, to continue working. Yeah, it's hard to believe. That's true. That's
Yeah,
it's hard
it
to
is.
believe.
It is. And when you're in a position like mine, and I think all of ours, there are so many things that we hear every day. For example, a cure for cancer has just been right around the corner for the last 40 years. They keep saying, oh, there's some kind of breakthrough. You'll read an article about some kind of breakthrough somewhere. In 5 years, we're going to have this. In 10 years, we're going to have this. And then 5 years passes, 10 years passes, and nothing actually happens. So I think when you're interested in technology, as I am, especially game-changing technology, you don't really know what is real and what is not real, especially if you're not in the lab. It's hard to separate what is actual science from what is science fiction. And so either we're going to look back on this in 50 years and say, holy shit, these guys are the greatest geniuses ever. All of worldwide energy demand has changed. Or they're just going to look at me as the idiot that I am because they'll say, oh, that guy, he just followed anything. It seems to me like you have made some real strides. So what's the roadblock? What is the hurdle that you're facing in the next year to bring this
but
out?
let me comment a bit what you just
Go ahead,
said.
dive
We are also not certain that we will achieve all the goals we are planning, but
sure.
we are absolutely 100% sure that this type of energy generation is possible, is very low, but it's new, and it's independent of many of the parameters happening with the other sources. It's free, and it will be always here, so in our atmosphere.
Around us.
Yeah, so
Correct or not?
yeah, when I thinking it's too big, when I start thinking on that, it's something incredible. That's why we will try, we will do our best during the next year to deliver this real scale device with the parameters we are mentioning for everyone to see it, to try and start some pilot projects with the companies, with the potential customers, for them to see how, for everyone to see how it works and how we can use it and operate.
Exciting.
Also, comment regarding the drugs, vaccination, and it's a bit different from what we are doing. And it's, as for me, it's much difficult to get to the market some new drugs because they passed much more stages than the electronic devices. And to prove the principles, working principles in vitro, then in vivo on the mice, then to go for the bigger animals, and then to human, it's take a while and it's much harder to achieve the final goal because there are many.
So that's why we are dealing
parameters.
with electronics. It's
That's
easier.
why. Yes.
No, I'm joking.
Easier to help people. Throughout human history, we've come across these things that seem like miracles. For example, you come to a country and it's full of trees and you say, hey, wouldn't it be nice if we just chop those trees down? Then we can have firewood and we can build houses and all of that stuff. One day you wake up and there's no more trees. Or you dig into the ground and you say, oh, look, there's oil, this stuff that comes out. I can burn it. I can make all this stuff. I can make cars with it. And then one day you look in the ground, there's no more oil when everybody starts driving a car. If everybody in the world had one of these machines, would it change the humidity in our atmosphere? Would it fundamentally deplete it and make our climate drier? Or would it have no impact?
Wouldn't say that it will not affect. Of course, I see two things here. First one, when we add more volume, which is our devices, we already have, by all these physical processes, we have redistribution of the gases between these new volumes, new surfaces. That is already decrease a bit the average level of humidity if we are talking about the closed volume. The second one is, of course, that the process of generation consumes the water. It consumes humidity. And here's we need to calculate the mass balance between what we produce and what it will use. Since we are still working on a low scale, we have no exact data on the numbers. We have some estimations, but it's too early to say how much it can affect. Yes, of course.
But it could change.
Yes, of course.
Climate. Yeah.
It's from the process itself, it is changing the humidity. First by absorption, second by generation process.
Right. And the output you said is hydrogen?
Hydrogen
or
and
what again
oxygen.
are the output? And oxygen. Okay.
Yeah,
So,
everyone
Also
asks the
what?
first question when we meet some engineers or someone who is in touch with technology, they ask, oh, how much can we use this for the generation of the hydrogen? I said, come on, we are talking about new source of energy and you just focus on hydrogen. No, the process is very low.
Because it has to pick it
actually
apart.
takes a
Yeah.
lot of time. So it cannot be used for it has nothing to do with the technologies that exist for the hydrolysis of water or getting the hydrogen from the water
Right.
molecule. Yeah, nothing to do with that. It's very low amount.
So, best
no way.
case.
So then, sorry, may I add that we believe that due to our estimation, it will not drastically change the ambient condition. So.
Okay.
Yeah,
Because I've heard it said atmosphere has, trillions of gallons of moisture. So the number is so astronomically large. Another person has said that on this show earlier. Genesis Systems, they were trying to get water from the air, not energy from the air. And I asked the same question, and his response was that it wouldn't affect it that much. There's so much water in the atmosphere. So I don't know. I just asked these questions. Best case scenario, 5 years. What do you think happens? All of the haters publicly apologize. All of the Redditors who are such geniuses, they say, I'm sorry, I ever doubted you. What is the best case 5 years from now the most realistic case for this technology and
The
your
most
company?
realistic one is that we are going to start sales on these modules. Yeah.
Do you see it
And
as more like a subscription service or something that you buy once?
we considered
and then...
some different options, and we recently changed our minds because we first were considering the B2C models, so the households were prioritized for us. But then we had some interest from very big players, very big companies, and they have absolutely unexpected to us energetic problems. We start preparing and changing the things for the B2B. So first we want to go there.
Yeah, that makes sense. That makes sense. I don't know how it is in Portugal. Here, if I wanted to install solar panels on a single-family home, $20,000 to $40,000 US, even with subsidies, it's not going to be very cheap. Do you think that this will be cheaper for the average person, and that they might say, "Hey, I was thinking about doing solar, but I'm going to do this
It
instead"?
depends also. So what is your consumption? What's your power you want to install the system? So the only thing I mentioned, the comparison would be this LCOE parameter, levelized cost of energy. So if we are competitive with solars or other technology, with the grid, okay, solars or grid, the rest goes from there. If we are competitive, then it's the choice of the person what to install. Maybe it's not a very common problem in United States, but in Europe, we have many old buildings, multi-floor buildings, and there is no space for everyone to install the solars to the roofs.
Right.
Yeah, so there is now a lots of technologies like some solar special ones that you can install on your window or something. It's not also very useful because it's too much dependent on the incident angle of the sunlight. So, and our technology can be installed, for example, on your balcony. And we will also, think so that for the smaller flats, we can have the half size of this module. So it will be meter per half meter. So it will be two times smaller, which can fit, the size. But of course, the generation will be less. But for the flats, 5 kilowatt-hours per day, it's something common. So
Up to 100 meters, I think it's
it will fit the needs.
Wow, that's incredible. So in the future where every single one of us is going to be mining Bitcoin constantly, every single one of us is going to have in our possession 600, 700 GPUs for our own personal AI farms, our own Bitcoin mining operations. Do you think that we'll be able to offset all of our growing energy needs as a species with clean energy sources in the next 50 years? Do you think that limitless energy is possible for us?
I'm not sure, because the demand is growing continuously. It's growing faster than the generation facilities. So this is the problem currently. So we were trying always to get rid of fossils, but we still cannot. And from year to year, the ratio between it's growing. So not growing, I would say more or less constantly between, at least I know the European data is it's around 34% of these is still fossils, and it's maintaining from year to year, despite we are getting closer and closer to the green transition, at least by some data and publication. Yeah, so that's why we believe that technology is needed, new technology, because most of the technologies, renewable technology, they are working almost at the theoretical maximum, so you cannot get more. And
so we need something brand
we will be
new
honest. So what our technology and the level what we are what we have right now, and we are already considering the first devices, it has very low conversion efficiency. So we are still at the very beginning of this process. It's around 1.5%.
Yeah. I've often felt there are many real problems that we're facing as a species. We're facing resource scarcity, fossil fuels, plastics, ammonia, rare earth metals. There are certain non-replenishable materials that we rely on and that our entire society is based on: concrete, all of these things, which at the moment we don't really have any great solution for as a species as our demand goes up. I've kind of always felt that as a rotating ball in outer space surrounding a very large star, that energy wouldn't be a problem that our species would face long term. Do you share my belief in that? I feel like energy will be abundant. We just need to tap into it. everything else will be a very real critical problem. That's just my personal
At least
belief.
we know what to do, how to get the energy.
Right.
This is, I wouldn't say this would be a big problem for humanity. Yeah, you're right. Absolutely right. I share your thought.
Right, we're constantly moving. We've got this giant ball of energy blasting at us. We got radiation flowing through us. It's hard to imagine that we'll run out of energy. We just need to find a better way to use it. So many things are in motion: water, air, sun. But storing that energy, food, buildings, medical devices, when fossil fuels, these are the things that I personally am more afraid of. But I think you're right. That optimism has to become real.
But you're also right with the point you mentioned regarding the storage. But if we are talking about supplying, for example, a car with the energy, the size is critical. The size of the battery of the storage media is critical. But if we are talking about the centralized house, of, I don't know, 100 to, I don't know, let's imagine 1,000 square meters surface of the walls, just walls, then is very big. So then you have enough space to put inside the walls and storage media and generation media. And I read some articles, scientific publication, where the cements are used as a storage media. So it's a good combination where you have your walls.
I got to meet these people. That's interesting.
I can try to search the publication.
I love that. That's super cool. That's a question I've been asking for a long time. I see my man Sergey glancing at his watch. Very impolite, Sergey. We have a show to do here. No, I understand that we have gone over time. We had some technical difficulties, which has been a hallmark. No, I completely get it. I'm sure you've got to. So let's wrap it up. For each of you, any parting words, anything you'd like to say about the journey or about ecotech or clean energy, renewable energy, any last words you'd like to say or advice for people who are heading down a road? Any parting
everyone
words
who has doubt, we invite to our lab to see what we are doing.
I like that. Put your money where your mouth is.
Yes. Or after NDA sign.
Yes. It's our IP service. They push us to to sign all these papers, but we
so
are
get to Lisbon,
open.
folks.
Yes, you're very welcome, Rose. We would be happy
I would love to. Next time I'm in Portugal, of course I'm going to stop by.
Yeah.
That
our lab
incredible.
is just next to the airport, so it's 5 minutes from airport of the Lisbon airport.
That's very convenient. I was literally just there.
Very
awesome.
convenient, yeah. And I don't know what to say to the people. I will just follow us, and and we will we will show that it's real thing. It's working.
Our main proof will be the prototype. Yeah, it will be the main evidence that it works, and we show to everyone as soon as we've got there. And of course, we are doing our best to be there as fast as possible.
And for those who want to follow along, the website, it's a bit English pronunciation. You would say it's CascataChuva.eu, which is CascataChuva.eu, but we've learned in Portuguese it's CascataChuva.
So
a lot of pronunciations today.
Cascata, it's like cascade, and Chuva, it means rain. So it's like cascade of rain. So it's like waterfall. Yeah.
That's beautiful. I love it. Right. We learn a little bit of Portuguese on this show from 2 Ukrainian men from Donetsk. And with that, let us all hope for a cessation of wars. Let us all hope that part of the world sorts itself out long enough that we can stop killing each other long enough to develop exciting new technologies like this one. I think it's awesome that you guys have dedicated your lives to this and that you take it very seriously. I also appreciate you taking the time to address the criticisms, and I am very pleased to have the chance to get to know you both. It's a very exciting technology, and I can't wait to see. I really genuinely hope that in the next 5 years you achieve this and that this becomes a part of that clean energy mix. It's just what a cool time to be alive. So thank you both for taking the time to join.
Thank you very much, Rod. It was a pleasure for us to be here. Yeah.
My pleasure. Thanks. All my pleasure. And with that, the official podcast is over.